Okay, so we're back. This is going to be part two of my videos on function notation for Algebra 1. In the previous video, we looked at functions and function notation in the form of an equation like this. And in this video, we're going to look at function notation in the form of a graph as well. And these two things can be related, right? Here's a graph. We're going to need to put some points on this graph in order to figure out what it looks like. But whether you look at a function as an equation or as a graph, they're kind of interchangeable. And we can look at them both through the lens of function notation. Still struggling with this program. Okay, so how do we do this? Well, we've got an equation here, f of x equals 5x minus 3. Let's fill out this table of values based on different values for x. We don't have to do the whole thing. Maybe we'll just do like 3 of the values. So for example, let's pick -2. What is going to go in this box? Well, when x is -2, we can ask what is f of x? In other words, what is f of -2? And I'm going to put this in a different color again because -2 here is our input, it's our x. What is f of -2? Well, we're going to, just like before, plug in -2 wherever we see x in our equation. So we've got f of -2 equals 5 times -2, 5 times x minus 3. Okay, so what do we get? We evaluate this. 5 times -2, well, that's -10 minus 3, so we get -13. And that is what will go in here in this box, -13. We could try it again at, say, the value 0. What is f of, now our input is going to be 0. If we want to fill in this box, we've got the same equation, so 5 times our input, 0. That didn't, a little weird. Let me try to erase that. Good enough. 5 times 0 minus 3. Oh, come on. That's a 3. Okay. 5 times 0, again, anything times 0 is 0, minus 3, so we get -3. Okay, so that would be our value for f of 0 is going to be -3. Let's do maybe one or two more. How about f of 2? Okay, let's do f of 2. 2 is going to be our input now. Equals 5 times value 2 minus 3. And we get equals 5 times 2 is 10 minus 3. 10 minus 3 is 7. So that was for 2 as our input. Our output is 7. Looks like our first point, so now we can put some points on the graph, right? Our first one would have been at when x, remember this is always x, this is y, and our y value is based on the output of the function. So I think this one's going to be a little off the graph. Maybe I'll skip that one. We can do f of 0, so when x is 0, which is right in the center, y, the output, is -3. So negatives are down here, 1, 2, 3. That's the point on the graph. When x is 2, so we can go 1, 2 up here to the right, our output was 7. So we're going to go up 7. 1, 2, 3, 4, 5, 6, 7. Close enough. And even though we didn't have another value on here, because I think it's off the graph at -2, would have been way down here somewhere. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, 11, 12, 13. Would have been way down here somewhere. And we could say, what kind of function is this? Oh, well, it looks like these points. Oh God, you guys know me. I can't draw a straight line on without a ruler. But this function is a line. And we got the points. The important thing here is that we got these points from filling in, evaluating, plugging these values in to this equation in function notation. Now let's take another look at a different kind of graph. Let me scroll down here, or a different kind of idea of graphing here. So here's a table of values, right? We've got some x values and we've got some y values, some inputs and some outputs from this function. We don't have an equation, and that's okay. We don't need an equation because we know, based on this table, for different inputs, what the output is going to be. So we know for these inputs, we know on the bottom here what the output is going to be. And that's enough for us to evaluate some of these expressions in function notation. So for example, we could ask, what is f of -3? Well, -3, this f of -3 means -3 is our x, or our input, right? So when the question is when -3 is our x, I don't know, okay. What do we get as our output? Well, we can kind of look across the table. Here's what we're looking for right here. When x is -3, what do we get as an output from this function? We get the value 2. So f of -3 equals the value 2. Similarly, we could say, what is f of 20? Well, looking at the table, here's where the input is 20. What do we get as an output? We get the value 0 right here. I should have circled this. So f of 20 equals 0. So there's a way to kind of translate these points. This as a point, we could say, is like, the x was 20 on the graph. Ooh, on the graph, the point would have been 20, 0. In function notation, that is the same as saying f of 20 equals 0. Let's look at some more here. F of 8. Can you take a guess what f of 8 is? If you said f of 8 equals 4, you are correct, because we're looking at this point right here, this pair of values in the table. Now here's a slightly different question. We could ask, if f of x equals 9, what is x? So does that mean we're looking for where the input is 9? Would it be 4? Well, not quite, because now it's f of x equals 9. So that now we're looking at when the output is 9 here, what is the input? The input there is 2. So what is x? X is, in fact, maybe I should put this in a different color. So talking about x here, the input was 2. If f of x equals 4, so again, this is the output, what is the x? So we're looking at when the output is 4, what was the input? The input here was 9. So in this case, it's 9. Now, these questions were different, E and F, because they asked us to find the input when knowing what the output was, right? This is telling us we know what the output is. Oh my God. You get what I'm saying, right? We know what the output is. What's the input? We could do the same thing with an equation instead of a table or points. For example, if we had this equation, f of x equals 2x minus 3, and we said, okay, if we know f of x equals 15, find x. If we know the output is 15, what's x? So in this kind of case, we have to say, we're not plugging this in for x, right? We're saying this is the output. This is f of x right here. So we know f of x is 15. What is x? Well, we have to set up this equation. So f of x is now 15 equals 2x minus 3. And can we solve that equation to find our input x? Find x, right? How do we solve this equation? So we kind of have to think again about back to solving two-step equations, right? How do you solve this? Well, first we have to add 3 to both sides. Remember, don't forget both sides. That will cancel out this negative 3, this minus 3. So on this side we get 18 equals 2, come on, 2 times x. And then how do we get rid of this 2 in front? Well, we divide both sides by 2. Divide this by 2. That is a 2, please. Thank you. Divide this side by 2. And then finally we get, when this cancels out, x equals 18 divided by 2 is 9. So this is a similar question because we knew what the output was going to be. We were asking what was the input. Let's do one more just to kind of show this again. How about we take this one. Here we've got g of x is 3x plus 2. If we know g of x equals 11, again, we're not plugging 11 in for x now. We're saying g of x right here, g of x, we know is 11. This is doing some funky stuff here. So g of x, we're going to replace that with 11 and solve this equation. 3x, oh my god, plus 2. It's something to do with the screencasting while I'm doing this. It's like slowing it way down. So how do we solve this for x? Well, let's get rid of plus 2. We have to subtract 2, right, on both sides. This cancels that out. We get 11 minus 2 is 9, equals 3x. And how do we get rid of the 3 in front? Well, we divide by 3. We get, that is a 3. Oh man. And we get x equals 9 divided by 3 is 3, was our input. So when 3 is our input, then the output is 11. Okay, so that is part 2 of this lesson, and I'm going to ask you to try and answer some of the questions that are similar to these as your kind of assignment for the week. If you have any questions at all, please feel free to ask me or Mrs. Baroni if you're in one of my co-taught classes. I am available in the mornings, and I'm very glad to walk through this with you kind of in person. Have a great week, everyone. I hope that you're all staying safe and enjoying your time off from kind of being in the school and finding ways to entertain yourself. All right. I'll talk to you guys later. Bye.